Okay. All right. Area between curves. Now, I need you guys to do a couple things here. So whenever we're doing these, there's a lot of things that we actually have to have. Okay? If you notice, to find the area of a curve, I do integration, right?
Yes.
And I do it between bounds, don't I?
Yes.
Yes? Now this is going to make our bounds. This is going to make our bounds. So now, whenever I do the area, I want the area
That makes sense.
of the top
You barely started teaching.
minus
But it makes sense already.
the bottom. Right? Because I do not want,
The bottom.
I do not want here, right? I don't want this.
You just want them. Oh. That's what already means.
I do not want that. I only want the area
Between the.
between.
That means. Wait, does red and blue make purple?
Yes, it does. That's why I use purple. You like that? Purple. Purple.
And the head.
Okay, so you made it. You notice. Now, couple things that need to happen here.
Double healing.
Couple things need to happen. I need to know where are their bounds.
Yes.
I need to know where their bounds are, right? So I need to know where they're going to be equal. On this one here, I have a graph. So I can pick numbers off the graph, can I?
0
So-
and 1, 2.
So it's going to be 0 and something over there, right?
Isn't it by 2s?
I don't know. I can't really tell. But do we have the functions?
That was 2, 4, 6.
X squared is equal to rad x, right? So I know I have y equals x squared. Actually, let me change colors so this matches. So the top was red, right?
Yes.
Okay. So I have y equals x squared.
That's blue.
You're right. Y equals rad x, right?
Yeah.
It just looks so red.
Are you guys paying attention?
Yes.
Okay, this is my function in red for rad x. Okay, my equation in blue is going to be x squared, right? So I know to figure out my bounds, I need to set them equal to each other. Where'd purple go? There it is. Okay, so if I set them equal to each other, it's going to be x squared is equal to
Rad X.
rad x.
Change the text to
Okay, what could I do? I want to try and set it equal to 0.
Subtract.
No.
X squared. Subtract 1 over.
Okay, do you want to do that? We can do that.
I want to do that. Why do you say that?
That's
You
the
made me
only-
say-
I don't like radicals.
X to the 1/2. Oh, you can multiply both of them by x to the 1/2. No.
Or I can square both sides.
No.
No?
Yes, you can.
You
Yeah.
can.
You can. Yes, you can.
Okay, so either way, so there's a couple different ways of doing this. If they're equal, I can. I'm going to start with the set it equal to 0. Okay. So I want to set it. Let's do that. So it's going to be x squared minus x to the 1/2 equals 0.
Well, now it's kind of weird.
No, it's not. Now, I'm about ready to say f that.
F that.
What am I effing?
X to the 1/2.
X to the 1/2. Right? And I'm left with
X to the 3/2.
3 halves.
Minus
X.
1. Supreme. I need to.
Okay, so now that that's factored, right?
Yes.
Now that that's factored, let's look. So now can I use zero product rule? Say yeah. So right here, so it's just going to be, this part is going to be x equals 0. This part right here is x equals 0, right?
Yes.
And this part right here, I'm going to have x to the 3 halves
Is equal to 1.
equals 1, right?
Yes.
And then
Cube it and square it.
cube root
Just square it.
and then square, right?
Cube it and square
So it's still going to give me x is 1. So my bounds for this would be from 0 to 1. It's going to be from 0 to 1. So it's a top curve. Now, figuring out what the top curve is actually, it's one of those things that you're going to have to know how to do. If you have a calculator, you can graph it. But if you don't have a calculator, okay, kind of like that. So we figured out the bounds, right? We know it's going to be here to here. But I don't know which one's on top. We're starting off with some basic functions here, so you guys should actually know. An x squared opens up. Rad x, kind of arcs out, right? Okay, so that I know that this one's going to be on top here, right? But if I don't know, what you can do is pick a number in between and evaluate it at that. So for this one, it would be a half, right?
Yeah.
So it would be a half. So in between my bounds would be a half. So I would plug in each one to see which one's on top. Eventually, we're going to get into some of them that are going to twist. So they're going to have more than one intersection.
Oh, then you're going to make multiple bounds?
Yes, you're going to have multiple bounds. Okay, so we're going to change. So eventually, we're going to get something like this, where we're going to...
Cool, but I do not want to get there.
Like this.
And it's a straight line passing through?
Something right here.
What if it was like sine and
So, now, I just sketched something to show you guys. So from here to here, it's going to be the top minus the bottom, right? Here. But over here, from here to here, isn't that going to change?
Yeah.
This would be the bottom minus the top from what I have here, right?
Yeah.
Does that make sense?
It's cool.
Okay, so this is an example of it changing more than once.
Would it not be the same area?
Huh?
Or both?
No.
Depends. For this one, I'm just sketching it. This is like an x cubed here. And then this is just like a linear, and it's somewhere in between. Where you would have to do algebraically to find where those points are. Okay, and then figure out what's on top. If you have a calculator, that's great. Graph it to see which one's on top. And then you can find your points, right? You could do intersection points on your calculator too, right?
Yeah.
Yes. To figure out where they intersect at, and then you could actually figure that out.
Those are some hacks.
Okay, they are on the test like that. All right, so we figured out what's on top. So here's my formula. Area is going to be the top curve minus the bottom curve. So I'm going to use fundamental theory of calculus and actually just break it up into two separate. So it's going to be of this 0 to 1, and my top was x to the 1/2, right? Dx minus the bottom from 0 to 1, and that's going to be x squared dx. So you could break it up like this. You don't actually have to have all of it like this. Because if you did, you would actually have to have these here, signifying all this with your dx. Okay, that's going to be a big thing where a lot of people lose points every year. Okay, on the AP exam, because the dx, if you don't signify that all this right here, you can do all the math in there, inside there, then dx. We could also just, combine them together, right? Sometimes you're going to have some type of, quadratic equation for one and a quadratic equation for the other. And inside there, you can combine them into one function and then find an integration of that.
Whoa.
You can, so you can combine them. Okay, so now what are we going to get here? So let's do the math. So it's x 3/2 2 over 3, right? Minus so it's x cubed over 3, right? But this is from 0 to 1, and it's also from 0 to 1. Right? Okay, so this is going to give me, what's that, 2/3? 0. So it's 2/3 minus, which is going to give me, there we go.
That is the
Area between the two curves.
Yep.
1/3.
The area of the region bounded by the curves above.
That's what it is.
Okay, find the area between these. So, how did I start this?
Just figure out each other's top and bottom.
Yep, top and bottom, and figure out your bounds. All right, let's take a look. So, bounds. My bounds are going to be what?
0 to 1.
0 to 1.
What did I do wrong?
What's my top?
2x minus 2x.
Negative 1/3.
2x minus x squared.
Oh wait, oh look at this. Oh,
dx minus from 0 to 1 x squared dx.
It's gonna be x squared.
So x squared minus x cubed over 3, and that's from 0 to 1 minus, so that's going to be x cubed over 3 from 0 to 1. 1 minus 1/3 is going to give me 2/3, right?
Yeah.
Minus,
I see what I did wrong. 3/4 is not more than 1.
okay, alright, let's take a look at the next one. Find the area of the region bounded by those two curves. Sine x.
Sine and cosine.
Now, I'm going to do a quick sketch so you guys can see this. This one is different. It said it's bound by sine x. Sine starts at 0.
To pi.
And here's pi, right?
And cosine starts at 1.
Cosine starts at 1. So we'll start here. And it goes here.
what the heck? That looks trash.
That looks good. It's not.
This one right here should be pi over 2.
That looks trash.
And it's bounded. It gives some other values here. So this is important. By x equals 0. X equals 0 is this. And pi over 2, right? So that means that it's going to be bounded right here also.
Thank God.
So, if I'm finding the area between the curves,
So left side and right side.
so let's take a look. Between the curves would be here
Would those two areas be equal?
and
The other one?
no.
The
It actually is going to be for this because this one's quite simple. And it's also, it's not this down here,
Makes a little mad.
but it is this right here, right?
Lucha.
Between the curves. Now, between this piece right here
It's not between.
is not between because this one, all this right here is, if I'm looking at it,
Oh, so we have to set up two separate ones for this one?
yes. This one right here, because I have an intersection here. I have an intersection here where these two, yes. Where are sine and cosine equal?
By quarters.
Pi over 4. Very good.
Oh.
So pi over 4. So, because of this, it's changing. So now, if I'm doing my integration, I'm setting it up now, right?
That's why I got pi 4.
So, I'm going to do my integration from, because I already drew it, I was given bounds here. Here and here. Right? So my lower bound is from 0 to what? Pi over 4. Right? So 0 pi over 4. And that would be my top. What was my top here? So it's cosine of x, right? Minus
Integration. Oh, sine x.
sine x.
All dx.
Okay, this is fundamental theory of calculus. I'm putting them both together because it's the top minus the bottom. Okay, it's the integration of the top minus the integration of the bottom. And if they're both integrating, I could combine it into one equation, right?
Yep.
Plus. Now, on my second integration, would be from where to where?
Pi
Pi 4
4
to pi.
Very good. So pi over 4 to pi over 2.
Hey, we're
Is
the
it the same way?
Do you know the way?
It's gonna switch.
Like,
Please don't.
would it switch, right?
Yes, it is. Because which one's on top now?
Sine.
Sine is going to be on top here, right? Because sine starts at 0 and it goes up and it right here it changes, right? So this one's sine is going to be on top now. So it's going to be the sine minus the cosine. So I've gone through and I did both parts here. Okay, so I could actually do these and actually start plugging stuff in. Okay, and then I add the two together because I'm adding this area here and then I'm adding this area together to get my total area in between the two curves. Okay, so integration of cosine is going to give me sine, right? So it's going to be sine x minus integration of sine. Negative cosine. So this is going to turn into what?
Positive cosine.
Plus cosine.
From 0 to pi 4.
Okay, and that's from 0 pi over 4 plus my other side, which is integration of sine, negative cosine, and it's minus the integration of cosine.
So it's gonna be
positive sign.
negative
So it's
cosine
gonna
plus
be
sine.
minus sign.
Okay, so think about it. If you include the negative, so negative cosine, the integration of negative cosine. Okay, do I need to draw the wheel?
Clock. Isn't it negative sign?
Okay, look, negative sine, sine, positive cosine, negative cosine, right? So, taking a derivative,
I'm good.
derivative is clockwise, integration is counterclockwise, right? So, negative cosine, do an integration of negative cosine is going to give me negative sine. So, this is minus sine.
Who did that?
From 0 to, actually no, the bounds are wrong. It's going to be from, yeah. So, pi over 4
Oh, what is that?
to, okay. All right, so from there.
Should I wait?
Now, what's sine at pi over 4?
Rad 2 over 2.
Okay, plus cosine,
Rad 2 over 2.
right?
Yep.
Yes. Minus my lower bound. What's sine at 0?
0. No.
0. What is cosine at 0?
1.
Right? Okay, so now I'm adding all of this. So,
You forget the bracket over there.
sorry.
Thank you, sir.
There you go. Okay, so now, upper bound. So, cosine at pi over 2.
Cosine.
2 over 2.
No, cosine at pi over 2 is 0. Remember, that's at 90 degrees, it's at the top. And there's a negative there too, so it's not going to matter. So, negative 0, so that's 0. Okay. Sine at pi over 2, so this is going to be
1.
minus
Negative, so
1,
negative
right?
1.
Minus? Wait.
Because it's, if I take it at sine at pi over 2 is 1, right?
Wait, hold on.
So it's minus the 1,
Yeah, never mind.
okay, minus my lower bound. So, my lower bound. So that's going to give me a negative
Rad 2 over 2.
rad 2 over 2. Yes, and minus
Positive?
another rad 2 over 2.
Negative 2 rad 2 over 2.
Okay, so now let's take a look. So let's go through, and this is going to give me. So add those together, and I just get what? Rad 2, right?
Yeah.
Rad 2 minus 1. This is going to give me what?
Negative 1.
Minus 1 again.
Minus
And then this, I have two negatives, and that's going to opposite that one, so it's going to give me just another
positive rad 2 over 2. 2 rad 2 over 2.
2 rad 2 over 2, which is just rad 2.
Oh, you're right.
So I'm going to end up with how many rad 2s?
2.
So it's going to be 2 rad 2
Minus
0. Oh, wait, I know.
minus 2. So, can you approximate that answer? Yeah.
It is going to be point
Okay, calculator. Do it quick.
0 point
No, 1 point.
0.818. No, it's
0.8284271247. Right, you're wrong.
Excellent.
I was close.